Alright, we've looked at ways to use an arc length to do other calculations. Now we're going to see how to calculate the arc length if it's not given. In general, arc length we know is something like this region here. I've got two radii drawn from the center of the circle to the edge. So what I'm looking for is this distance, or even this over here is an arc length as well. We're going to focus on the yellow distance just so we can be specific here. In general, an arc length is a percentage of the total arc length, right? Total arc length, of course, being the total distance around the circle. And we know the total distance around a circle has another name. It's called the circumference. Alright? So that's the general strategy. This is the way I remember to calculate arc length. Now, if you want to go even further, how do you calculate the percentage of a circle? Well, if this angle is theta, and let's use radians so that they're unitless, if this angle is theta, then the percentage of the circle is the partial angle theta divided by the total angle 2 pi radians. If you use degrees here, the bottom would be 360 degrees for the total angle. The circumference of a circle is, well, we need something on this circle to tell us how big it is. So let's indicate a radius of r, some number r. Then the circumference is 2 times pi times r. If you were to simplify this now, the 2's would cancel, the pi's would cancel, and you would simply get your angle theta, which is in radians, don't forget, times your radius. And that is how you calculate the arc length of a circle. You multiply the angle by the radius. I never memorized this formula. After you do so much with it, sometimes you tend to remember it. However, I tend to think of it as a percentage of the circumference. It's a very natural thing to remember. But here's an interesting way to do it as well. Now let's, instead of using a radius of some general number r, let's use a radius of 1. And let's say 1 foot, okay? Be specific here. And let's come back here and let's give a specific radian measure so we can really sort of understand what's going on here. Let's say that this is, I don't know, it looks like maybe 2 radians. And so the neat thing about this is, if you remember, the number of radians is the arc length divided by the radius. Well, what's so nice about having a radius of 1 is, if this is 1, the arc length divided by 1 is the arc length. So, this is interesting. If the circle has a radius of 1, by the way, this has a special name. It's called the unit circle. Unit meaning 1. Unit circle has a radius of 1. If you have a radius of 1, the angle in radians equals the arc length. So, if we come over here, notice the angle is 2 radians, so the arc length up here is also going to be 2. But of course, the unit is not radians. Arc length is a distance measure, so it's going to have the same unit as your radius. So the arc length here is 2 feet. It's very nice. If you look at a circle of radius 1, the angle and the arc length match. Now, you might be thinking, well, that's neat, but that doesn't relate to all the other circles out there. Well, in a way it does, so let's take a look at that. So here, this radius is clearly bigger than 1 foot. Notice the angle is still the same. These circles are similar, right? One is just stretched bigger than the other. If I tell you that this radius is 1.5 feet, all I've done is I've multiplied my circle of radius 1 times 1.5. So that means my arc length is also going to multiply by 1.5 to give me 3 feet. So, if you use a radius of 1, the angle and the arc length match, then you can change your radius here to whatever you want by multiplying it by that number, and your arc length also multiplies by that number. So if your angle is theta in a circle of radius 1, your angle is theta in this circle. But if your radius is r, then your radius over here is going to multiply by r, and your arc length is going to multiply by r also.